Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Toward the end of the Ice Age, approximately 12,900 years ago, the Earth was warming and the ice sheets were retreating, but suddenly the climate became colder and returned to glacial conditions for approximately 1,300 years. This cold interval is called the Younger Dryas cooling event after a flower called Dryas octopetala that grows in cold conditions and became common in Europe during this time. The cold interval is more recent or younger than other cold events during the Ice Age. Scientists have proposed several causes for the sudden cooling, including changes in ocean circulation, a volcanic eruption, and cosmic impact. The cosmic impact hypothesis has a large number of supporters, but there are also a large number of dissenters who demand to know the location of the impact crater. The Younger Dryas cooling event is associated with changes in North America that included the extinction of many large animals, the so-called megafauna. These animals included mammoths, giant short-faced bears, and large cats such as Smilodon, the saber-toothed tiger, as well as the American lion, which was 25% larger than the modern African lion. The extinction of the megafauna also coincides with the disappearance of the Clovis culture, which is known from its finely crafted stone tools. Scientists generally favor one of two explanations for the extinction of the megafauna. The first is that human overhunting directly caused the extinction, or that the elimination of keystone species led to environmental collapse and a wider extinction. The second explanation is that climate changes disrupted ecosystems by eliminating food sources or by exposing animals to climatic conditions to which they were not adapted. Proponents of the cosmic impact hypothesis point out that the megafauna had previously survived colder conditions than the Younger Dryas, and that the humans who had recently arrived to America were not numerous enough to have exterminated all the well-established megafauna with their stone weapons. In 2007, Richard Firestone and 25 co-authors proposed that an extraterrestrial impact caused the extinction of the North American megafauna and triggered the Younger Dryas cooling event. This became known as the Younger Dryas impact hypothesis. Firestone's paper reported microspherules and nanodiamonds at the Younger Dryas boundary as evidence of an extraterrestrial explosion over North America that destabilized the Laurentide ice sheet and caused extensive biomass burning. Samples were taken from 15 Carolina bays because previous authors had proposed that the bays had originated from an extraterrestrial impact. Firestone was severely criticized for not providing the traditional evidence required to prove an extraterrestrial impact. Firestone replied to this criticism in 2009 by maintaining that the spherules at the Younger Dryas boundary were suitable indicators of an extraterrestrial airburst, and that the conflicting dates for the Carolina bays could have resulted from inadvertent sampling of older sediment that may have shifted over time. Firestone proposed that a meteor had exploded in an airburst because no extraterrestrial impact crater had been found, but he also suggested that the Laurentide ice sheet could have shielded the ground and prevented the formation of a typical crater, and that the Great Lakes could be the scars left by pieces of a disintegrating comet. Firestone considered that the radial alignment of the Carolina bays and the Nebraska rainwater basins could have resulted from the wind of a shock wave produced by an extraterrestrial explosion in the Great Lakes or Hudson Bay. In 2011, 7 university professors from the US, the UK, and Austria collaborated on a requiem paper declaring the death of the Younger Dryas impact hypothesis. In the Roman Catholic Church, a requiem is a mass for the repose of the souls of the dead. The paper went point by point over Firestone's claims and showed that none of his evidence could be conclusively considered indicative of an extraterrestrial impact. Firestone's papers had not shown an impact crater, meteorite fragments, lithographic shock metamorphism, enrichment of siderophile elements, or other criteria established by impact science. The microspherules reported by Firestone had not been established by any previous research as a specific characteristic of extraterrestrial impact. The Requiem paper asserted that the Carolina bays had been created over a long period of time by episodic formation processes. The Requiem paper firmly established the battle lines between proponents of the extraterrestrial impact hypothesis and those who supported ordinary terrestrial mechanisms to explain the extinction event. The Requiem paper was very influential in stopping funding and research on the impact hypothesis and the Carolina bays. In spite of the efforts to kill it, the idea of an extraterrestrial impact at the Younger Dryas boundary refused to die. In 2012, several papers evaluated the microspherular evidence, and additional microspherules were found in Mexico. In 2013, Whitkey and 27 other collaborators quantified the amount of microspherules attributed to an extraterrestrial impact across 4 continents. Although the microspherules continue to be contested as evidence of an extraterrestrial impact, the large platinum anomaly reported by Petayev and his Harvard University co-authors added additional support. The platinum spike found by the Harvard team was definitely a siderophile element that could have originated from an extraterrestrial impact at the Younger Dryas boundary. Although Firestone had commented on the radial alignment of the Carolina Bays, much of the Younger Dryas impact research focused on microscopic evidence. Some impact researchers even considered the study of the origin of the Carolina Bays as a distraction from the real Younger Dryas boundary research. The Carolina Bays are shallow elliptical depressions with raised rims on unconsolidated ground whose major axis is oriented toward the Great Lakes. The size of the bays varies from about 100 meters to several kilometers in size. The bays are found on sandy soil close to the water table along the east coast of the United States. The radial alignment of the Carolina Bays may be the best clue for finding the location of the extraterrestrial impact. The Nebraska rainwater basins have the same elliptical characteristics as the Carolina Bays, but they are located in terrain that has been greatly degraded by wind and water erosion. Before the discovery of the Nebraska rainwater basins in 2001, early researchers assumed that the Carolina Bays had been created from extraterrestrial material coming from the northwest. The southwest orientation of the Nebraska rainwater basins made it possible to triangulate a point of convergence by the Great Lakes. By 2010, Michael Davies had integrated hundreds of LiDAR images of Carolina Bays and Nebraska rainwater basins with Google Earth. He used great circle trajectories adjusted for the Coriolis effect to calculate the convergence point of the bays in Saginaw Bay, Michigan. Previous attempts by others to find the focal point had failed because they had used straight lines on flat maps and they had ignored the flight time of the projectiles. Davies benefited from the wide availability of LiDAR data and Google Earth to perform the triangulation. The Carolina Bays and the Nebraska rainwater basins have a mathematically precise elliptical geometry with similar width-to-length ratios, even though they have different axial orientations and they are separated by 2,000 kilometers. The Nebraska and the East Coast features are both conic sections that correspond to cones inclined at about 35 degrees. With this new knowledge, the explanation that the Carolina Bays were made by the action of wind and water does not make sense. It is highly unlikely that aeolian and lacustrine mechanisms could create shallow elliptical depressions with identical geometry in Nebraska and the East Coast radiating from a convergence point in Michigan. The answer to this puzzle requires an extraterrestrial impact. In 2009, the TV program NOVA popularized the Younger Dryas impact hypothesis. Overhunting by humans and climate change were discussed as possibilities for the disappearance of the mammoths and other large animals, but an extraterrestrial impact was considered a very likely cause of their extinction. In the program, Professor Peter Schultz demonstrated that a layer of ice could shield the surface and prevent the formation of a crater. All his experiments showed that a high-speed impact on an ice sheet produces many pieces of ice that are ejected radially in ballistic trajectories. The intersection point of the Carolina Bays and the Nebraska rainwater basins in Saginaw Bay was covered by the Laurentide ice sheet during the Ice Age. The ice sheet was approximately 2 kilometers thick. An extraterrestrial impact at this location would have ejected pieces of glacier ice in ballistic trajectories. The powerful secondary impacts of the ice boulders on the sandy soil of the Atlantic seaboard would have liquefied the ground and made it possible for the projectiles to produce inclined conical cavities that later transformed into shallow elliptical bays. The bay geometry, the ballistic equations, and power laws relating impact energy to crater size provide the mathematical foundation that explains the origin of the Carolina Bays and the Nebraska rainwater basins. The glacier ice impact hypothesis, published in 2017, proposes that the saturation bombardment by the ejected ice boulders with energies of 13 kilotons to 3 megatons was the major cause of the megafaunal extinction within a radius of 1,500 kilometers from Saginaw Bay. The hypothesis also proposes that the water ejected above the atmosphere by the extraterrestrial impact would have turned into a fog of ice crystals in low Earth orbit that blocked the light of the sun and triggered a cooling event. The latest Younger Dryas boundary research has focused on the biomass burning caused by the cosmic impact. The passage of the meteorite through the atmosphere would have ignited forests and caused widespread burning. The smoke from the fires would have blocked the light of the sun, causing a cooling event. Critics of the impact hypothesis will continue to say that fire and smoke are not sufficient evidence to prove an extraterrestrial event, and they will keep asking for the location of a crater with shock metamorphism, shatter cones, and other well-established high-speed impact evidence. This image of the Lake Huron bathymetry is marked to suggest that the impact at Saginaw Bay could have come from the southwest. The point of the arrow is at the deepest point of Lake Huron, and it is remarkable that Saginaw Bay is aligned with the deepest point. The curvature of the bathymetry seems compatible with the shock waves of a projectile coming from the southwest. A meteorite approaching the Earth tangentially from the southwest would have produced intense radiation capable of starting fires in a large area extending from southern Missouri to Michigan. Firestone suggested that the deep holes in the Great Lakes could have been caused by cosmic impacts. Lake Huron seems like the best candidate for exploration based on the morphology of its bathymetry and the convergence of the Carolina Bay's axial orientations at Saginaw Bay. Geological examination of cores from Lake Huron and from the northern rims in Canada may provide the type of hard evidence that the critics have been requesting. The meltwater from the Laurentide ice sheet could have washed away much of the impact evidence, but there may still be some traces that could finally settle the question about the location of the Younger Dryas impact crater. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.